Hello and welcome to another video on composing with OpenMusic. In this video I wanted to respond to a wonderful question that a viewer asked about, I think it was the rhythm quantization in OpenMusic video. And from what I was able to gather, this viewer was really interested in looking at some of the rhythmic techniques used by the amazing composer Brian Ferneyhough. Hopefully you're familiar with some of Ferneyhough's music. If not, I'd highly recommend looking up his work and the work of other composers of the new complexity style. It's just really fascinating and interesting music. In any case, this viewer had seen a wonderful video put out by Samuel Andreyev on a work of Ferneyhough's. And in the video, Andreyev does a wonderful job of explaining some of the rhythmic techniques that Ferneyhough uses, specifically with the software Patchwork. Now, OpenMusic is actually kind of a spin-off or maybe a development of Patchwork. Patchwork was kind of the first iteration of this computer-assisted composition software. Eventually OpenMusic kind of branched off of that, and the two have been kind of developing in parallel now for many, many years. In any case, this viewer had wondered about, I think, a way of implementing Ferneyhough's techniques in Patchwork or in Super Collider. And while I'm fascinated by those two pieces of software, I don't have the experience at this point to know how to use them. In any case, I thought I would just quick show a way of implementing this process in OpenMusic. But first of all, you may want to take a quick look at the video that this commenter was referring to, where Andreyev gives an explanation of the techniques that Ferneyhough uses, and I'll either post a link in the description of the video, or maybe a little title card for you to click on here. So take a moment, watch that description, and if that's something that interests you, come back and we'll take a look at implementing that in OpenMusic. Alrighty, well, let's pop over here to OpenMusic, and I've just opened a new patch, and as in other videos, what I'm going to do is just kind of step-by-step walk through this construction that I've done to produce this kind of Ferneyhough algorithm. So what I'm going to do is I'm just going to set up two lists that we'll be working with based off of the technique that Andreyev is looking at in his video. So we're going to have some durations, just a simple list here, and then what I'm going to do is I'm going to make another list that will just be kind of a placeholder for the structure or the hierarchy that you saw in the examples that Andreyev shows. So this is just a way of representing kind of a vague general list that has this sort of hierarchical structure. So each of these letters are just kind of a placeholder for where one of these numbers might go, if that makes sense. All right, so the first thing we want to do is come up with a way of rotating this list of durations. If you remember from the video on Ferneyhough, these are rotated through. So you have the list 1, 2, 3, 4, 5, 6, and then maybe you have 2, 3, 4, 5, 6, 1, 3, 4, 5, 6, 1, 2, etc. So what we're going to do is we're going to come up with a way of doing that. So what I'm going to do is I'm going to make this object here, and it's very helpfully called rotate. And I'll just quick demonstrate what this is going to do to the list. If you look down here in the listener, we've of course rotated kind of forward in the list by one place, and that's all well and good. What we'll want to be able to do though is come up with rotations starting on 3, 4, 5, and 6 as well. So what I'll do is I'll click here, I'm going to hold down Control-Shift and then type the period or the greater than key on the keyboard and add this second inlet. And for the moment, I'm just going to leave this here. We're actually going to use this patch in lambda mode in a moment. And if you're unfamiliar with that, I'll explain that really briefly. But for the meantime, what I'm actually going to do now is add a length object and connect this up. And this length object is just going to return how many items there are in this list. So we get number 6, which is great, exactly what we want. And now what I want to do is actually subtract 1 from the result of this length object so that we get 5. And now what I'm going to do is add this arithmetic series object. And what this is going to do for us is create, oops, let's bump that over. This is going to create a list that will just step from 0 up to 5 in increments of 1. So, as you're looking at this, you may be thinking, wow, this seems kind of redundant. Couldn't we have just taken this list and connected it up to this subtraction object and get the same result either way with a lot fewer objects? And of course we can do that. But eventually that's not going to serve the purposes actually of this object. What we're trying to do is generalize this process as much as possible. And what this arithmetic series object is creating isn't actually related to these durations. It's creating a list of indices. So I'll explain that right now by showing you how we're going to use it. So we're going to connect up this list of indices over here to the right inlet of this mapcar object. And then we're going to connect the output of rotate to the left inlet. All right, and then finally we're going to go click on rotate. We're going to press the B key, B as in Brian, and then we're going to click on that little X until it turns into a lambda sign. And again, I apologize if you're already familiar with this, but maybe for those viewers who aren't. What we've just done is we've set up this mapcar object so that for each item of the list that it gets in the right inlet, it will apply this function. So basically what we're doing is we're saying, okay, we want to rotate through this this list up here, 1, 2, 3, 4, 5, 6, and we want it to rotate through on the 0th item, so starting with 1, on the first item, starting at 2, on the second item, starting on 3, etc. So this arithmetic series list becomes a list of places where we're going to start the rotation process. And that's why this arithmetic series list needs to be constructed this way instead of simply subtracting 1. Because, what if our list of durations actually began with something like a 6 and had a different duration in there somewhere? Then it actually, subtracting 1 would not serve the purpose of creating a list of indices where we would like to begin rotating the list. In a list of only 6 objects, we can't start at the 7th placeholder. Or I should say at placeholder 7, since we're actually starting counting at 0. Anyways, I hope that kind of makes sense why we're setting this up the way we are. It's not to be just Byzantine in the way we're constructing this patch. It actually serves a very important purpose. All right, so evaluating this mapcar object, we see that we get a list, just like we would hope, of rotations of our original list of durations. And because we've set it up to cap it at really at 5, stepping from 0 through 5, it turns out just like we would hope, which is excellent. Great. So this is actually just the very first step in a much larger process. So we're going to set kind of this whole portion of this aside for the moment. And we're going to go to work now creating a couple of sub patches that will begin serving a different purpose. All right, so what we want to do is we want to take these numbers, each of these lists that we've created, and basically fill in these letter slots with these lists while keeping the hierarchical structure of this list. And so I came up with a way of doing that. I'd be very interested if you're a longtime OpenMusic user and you have a more elegant way of doing this. I'd love to see that. But I think maybe what I've figured out is is at least an elegant way of doing it. We'll see what actually happens. All right. So what I'm going to do is I'm going to create an internal patch. I'm going to right-click and then select that there. And I'll just call this maybe mapping function because again we want to be able to map the list of durations onto this kind of placeholder list here. Now I'm going to make 2 inlets and 1 outlet, and right off the bat I'm going to start with an OM loop. So I'll double click OM loop, and I'm going to hit Control-Shift greater than or period, and go ahead and add 2 inlets to that OM loop object and connect this up. Alrighty, so for now I'm going to name this, let's call it pair number and letter or position, something like that. And we'll open this up. And so what we want to do is, whatever the first letter is, whatever the first number is, we want to pair these together and make a new list of the pairs of these 2 lists. And this actually is something where there's probably a specialized function. I think I've used one in the past, a kind of a specialized function that can actually do this more quickly. But for now, I'm just going to go ahead and make this here in this loop as an example of using loops for those of you who might be new to the software. So oftentimes I would use something like this list loop to iterate through the objects of a list one after the other. But in this case, we want to be iterating through objects in 2 different lists. So I'm going to go ahead and use for loop, and I'm going to add a length object so that we know kind of the upper limit of our indices of this list. And then I'm going to subtract 1 so that we don't call for an object in the list that is one placeholder past the edge of the list. All right, so this is going to set things up to iterate through the lists. And one thing I should say is that this loop and this patch as a whole will always assume that there is an equal number of placeholders and durations. So I can't have 5 durations and 6 placeholders with 1 kind of left out. So we're going to be assuming that there's the same number of objects in both lists. And right off the bat, what I want to do is flatten the list that represents the structure of the rhythm tree that we'll be using down the line. So instead of A, B, and then the parentheses, C, etc., it'll just be A, B, C, D, E, F, G, and only the outer 2 parentheses on either end. Great, so now I'm going to add a couple nth objects, and these just select a given object from a specified list. So we're going to call for the same position object in both lists. That's what we would like to do with these nth objects. All right, and then finally I'm just going to add x append. So this will make a new list with these two items as entries in the list. We'll collect these results, and we want to be collecting each time, and then finally at the very end of this process returning the results. So we'll save that, close that, and evaluate. Oops, and I must have done something wrong. Let's go ahead and take a look and see what I messed up. Oh, no, we're good actually. So the reason why I'm not getting results down here is because I'm still within this patch, and I haven't set default values for either of these inputs. So I think we're actually good. What I'll do is I'll connect this up here and step out of the patch for a moment. And I'm going to connect up. Let's see, what do I want to connect? Oh, here's what I want to do. Let's do, well, actually, you know what? I'm going to have to wait because there's still another portion of this patch. That's all right. So I'm going to assume, this is matching what I've got in my test from earlier. So I'm going to assume that everything is working correctly and carry on. So what I want to do now is add another OM loop. And I'll call this maybe mapping, something like that. And we'll add two inlets. We're going to take this outlet here, connect that up, and take this there. So what we've done in this OM loop is made a list that associates corresponding durations and kind of placeholder letters. So now in the next step, this is where things are actually going to get a little bit involved. And this was actually kind of the most puzzling and actually really fun, kind of intriguing part of creating this patch, because it uses a really special type of what we call an iterator. So instead of this collect iterator that is often used, we're actually going to be ending up using the accumulation iterator, which has kind of some weird and interesting uses. So in fact, accumulate is, at least for me, has been so tricky to use. I'm just going to go ahead and pull up the documentation so that we can take a look together at how this works. So let's go ahead and do this. And I'm also going to open up the manual because I think the manual does a little better job explaining. So let's do this. And we'll just do a quick search for iterators. Okay, oh, here we go, accumulators, yeah, there we go. Okay, so this, this little chart and this example here, these are really critical for understanding how this accumulation object works. And even with these really helpful descriptions, there's still parts of this that are really tricky, as we'll see down the line. So I've had to, whenever I've used this accumulation object, I always have to open up this documentation and just remind myself what's actually going on here. The idea, and this example kind of explains it pretty well, the idea with this is that we want to begin with an initial state here. What we want to do is actually begin with this state and apply the same function again and again. So in this case, we're subtracting. So 100 minus, and then we get a list of values here. So 100 minus 8. And that's all well and good. if we weren't using accumulate, what we would get is 100 minus 8, 100 minus 2, 100 minus 3, 100 minus 9. What accumulate lets us do is take 100 minus 8, which results in 92. 92 minus 2, 90. 90 minus 3, 87. 87 minus 9, 78. So at each step after the function has been applied, we kind of save the result and use that as the initial condition for applying the function again in the next step. So that's what this accumulate object is doing. And again, this is a really powerful feature, but it can be kind of tricky to understand at first. All right, so we'll just go ahead and connect those up. And on the outside, this actually will be fairly straightforward. So we're going to iterate through the list in input 1, connect that up here. So this is the list that we want to iterate through. This input is going to be our initial state. And then we're going to create an internal patch, and we'll have to set it on lambda mode with 2 inlets. And that's, if you look at the example over here, that's like the default for using accumulate. You have an object, it's set on lambda mode, and it has 2 inlets, as opposed to other cases like earlier when we used mapcar. Like out here we used mapcar, and our rotate object only had 1 open inlet. In this case, it's got to be 2. All right, so we'll call this maybe mapping or something like that. And we'll open this patch, and I'll pull up my example. And it'll actually be, again, fairly straightforward. We'll have 2 inlets. We'll put them here in the middle. So in this second inlet is going to be this loop that we're iterating through. Or the list that we're iterating through, and the list is a group of lists. In fact, how about I show you the structure of what this is going to look like when all is said and done. So the list that we're going to be working with will look like this: 1A, 2B, 3C, 4D, etc. So that's going to be the format of the list with the remaining items here. Okay, so now that you've gotten a chance to see that, pull these all back up. So what we want to do, taking in that list in the input from the second inlet, is separate these items out again. So we're going to do first and second. So this is going to pull out the number, so like 1. And the second is going to pull out the placeholder, A. We got those. We're going to add a substitution object. And like you might imagine, we're going to substitute the placeholder letter in this old inlet for the duration number in the new inlet. And then we need a list to actually be applying that to. So our list will come in through the first inlet, and it'll be applied here. And the results will go out through this output. And it's actually really critical that these these 2 inlets not be interchanged. So the patch actually won't work if the list objects comes in through input 2 and are kind of paired, 1A, 2B, 3C comes in on input 1. It actually has to be set up this way, and this is kind of an idiosyncrasy of the accumulate object. And again, this actually isn't something that's particularly clear from the documentation, and kind of the only way that I was able to figure out was by realizing, like for example, with this OM subtraction object, our initial state would be this first inlet, and the list that we're iterating through would be the second inlet. So kind of analogously, in this mapping patch that we'll be using on Lambda mode with this accumulate object, our first inlet, our initial state, has to be this structured list. And the second inlet has to be the paired 1A, 2B, 3C, 4D, etc. So this is fairly abstract, but I hope this is making sense. So we're going to go ahead and connect that up. Press B to lock the patch, and then click, click, click until it's on Lambda mode. And I think that should be it for this part of the patch. So let's go ahead and we'll close out of this. We've got that set up, and we'll go back to the highest level of the patch here, and we're going to connect up our initial state there. And we're going to make another map car object here, connect that up, and then connect that up here. And finally, we're going to go ahead and lock this patch, click until it's on Lambda mode, and we should be ready to go. So again, what's going on in this patch now is on the left-hand side, we're creating a list of rotations of this duration list here. And so this list itself is 6 items long, 1, 2, 3, 4, 5, 6. And we're asking this map car object to go one by one through those 6 lists in this kind of mega list. And it's going to go through each one of those and map these duration values onto these placeholder letters. So let's see if that indeed is what we're getting as a result. I'm going to click map car and evaluate. And lo and behold, yeah, here we go. So I'll pull this out so we can see better. So in each of these, the parenthesis structure of the list has been preserved. And sure enough, we can see the numbers actually rotating. So here it starts on 1, 2, 3, 4, 5, 6. So this is actually exactly what we want to be doing with this to produce these kind of rhythm trees that we'll be working with. Wonderful. Okay, so the last step that we need to do now is create another subpatch that is going to be producing the voices, the voice objects, by which we'll actually be able to turn this into notation. So we're going to make another internal patch. We'll go ahead and right-click, patch, and I'm going to name this produce, we'll call it rotations. That's probably more accurate. Produce rotations. Okay. So we'll open this up. We're going to add 3 inlets. And we're going to make an nth object. And let me see how we want this to be connected up. Okay, so the first inlet will go here. Second will go here. There we go. And then we're going to make a list object down below. So we'll click on this, Control-Shift, period, period, greater than, to add those inlets. Connect that up, and then connect this up. All right, so what we're doing is we're actually, this is just kind of an involved way of getting each item from this list into the type of tree structure that a voice object can read. So if you're curious about why we're going to be structuring this the way we do, go ahead and take a look in the documentation. If we go to score objects, rhythm trees, and then rhythm tree structure, what we're going to be doing is basically, so we have we have this part of a rhythm tree, and we want to add in a time signature and add in this question mark, which will tell the voice object that we're not sure at the outset how many measures we'll need to use. So that's basically what we're doing. This patch is just going to be taking each of these 6 rotations from the list, the results here, and taking each of those and formatting it into this type of list. All right, so getting back to this patch, we've connected those up. We're going to do one more list. And then one more list. So again, we just kind of, we have to create a couple of layers of parentheses to wrap our results up in to make it readable for a voice object. And on this last list, I have 2 inlets, the second of which is hooked up here. And on the first, I'm going to add a question mark so that in our final list, it'll be readable by the voice object that we'll use. So finally, I'm going to add a voice. I'm going to connect this list to the tree, the rhythm tree inlet. I'm going to add an output from this patch. And I want to pass this voice itself as a result. So I'm going to connect it out of this self outlet to the output. So what I should get from this patch is a list of 6 voices. All right, so we're going to come back here. We're going to connect mapcar to this second inlet. I'm going to go ahead and shift click on this last inlet, and this will be our meter. For ease, I'm just going to set this to 4/4. And then finally, I'm going to add one more mapcar. We want to apply this produce rotations function to the results that we got from an earlier step. So in this case, the results are these indices. So that's going to be our list that we'll use. We want to iterate through 0, 1, 2, 3, 4, 5 at each stage. And then the function again that we're applying is this produce rotations patch that we've just built. So we'll lock it with B, click until it's on lambda mode, being used as an anonymous interpreted function. And then finally, we'll go ahead and evaluate here, and we get a whole list of voices. So if we want to actually see these in notation, what we'll do is we'll add a poly for polyphony, a whole collection of voices, and we'll attach it to this voices inlet, which takes a list of voices as an argument. All right, so this patch is done now. I'm going to go ahead and evaluate this, and we can see we get this beautiful, complex kind of mess of notation here, like we might expect from this process that Ferneyhough developed. And so each of these going down is a different rotation of these items that we have here. I'm actually going to pull this over so we can actually kind of investigate this a little bit. Let's see. All right. So we can do some really fun stuff now. Because this is a generalized patch, you can have more than 6 items or fewer than 6 items. So I'll just add a 7 and an 8, and then a couple more G and H back here. Bump that over and evaluate this again. And yeah, we get a different result this time. Yeah, oh, this is really cool. And again, I have it set so each of these are, rhythmic duration ratios is dividing 4 quarter notes, but you don't have to have it set up that way. You could have it divide 15/16 if you wanted to be be a little different. You can have it do 2/8. You'll get some different beaming there for sure. So again, you can also, let's go back to 4/4. There's also, you can, let's see, you could substitute out a letter, and that'll change your results again. So let's see actually the effect that has. So we have G second from the end on both ends. And we can see, we get 8/1, 7/1, 1/2, 8/2. So we've duplicated that value, and I guess it must be starting from the beginning of the list rather than taking that 7. So yeah, you can do interesting stuff with that. You could, of course, make all of this even more complex by adding more, hierarchical layers of parentheses. I don't think it'll even process that. Let's see about a different part of our rhythm tree. Let's see if that'll run. Yeah, there you go. Yeah, so again, you can get some really fairly complex results, and the virtue of doing this way is that you do end up with a way of separating out the hierarchy, in this case resulting in these nested tuplets, from the actual durations and from how they're being rotated. And again, you don't even have to stop with rotation as the way of developing these rhythmic ideas. You can certainly be using other techniques or approaches. You could flip the list backwards. You could have the list be subtracted from another list of durations, or in some way connected to the pitch content that you're working with. And again, it'll, as long as it's the same duration as the hierarchy kind of placeholder list, all you need to do is take that new development of the rhythm and apply it to the same structure, and you'd get some perfectly usable results. So I hope this has been helpful. Hope that this gives a little bit more insight into the power of working with OpenMusic. In this video we saw specifically using that accumulation function in OM loop, and what an amazing thing that is to be able to use in your patches. So yeah, if you have any questions about this, this is a pretty abstract patch that we've built. Go ahead and leave a comment below. Hopefully this video is useful. If you'd like to see more of these, go ahead and subscribe. Click the bell to get notifications about new videos. And again, if you have some suggestions for ways of improving, streamlining this patch, go ahead and let me know. Well, thanks again. Hope that this video was useful, and I'll look forward to visiting with you again in subsequent videos.